like you want to be able to kind of move through this list. Now, quick sketch of this, it is a parabola. It looks something like this. So you want to be able to make that quick sketch from either knowing what it looks like or there's information here. And then we can write the end behavior, the limit as x goes to positive infinity. Sorry, that's a different class. Whoops. Right, as x goes to infinity, um, that's to the right. So imagine you're on the curve and you're going to the right. Right, right, right. Okay. If you're going to the right, what happens with the y value?
We're going to the right, the y value would decrease.
It goes down forever. So you would say f of x
Negative.
goes to negative infinity. Does that make sense?
Yeah.
It's going down. Now we go the other direction as x goes to negative infinity. As you go to the left, f of x goes to what's the y value going to?
The y value uh, negative infinity. It'd be negative infinity.
Oh, yes, goes to negative infinity. All right. Um, so like all of this stuff, A, B, C, D, like leads to this. Like this is what the teacher cares about is what's down here in the bottom. You have to write this most likely. You'll probably be asked to write this. Do you remember the four graphs that we talked about the other day? Do you have those still in your notes, or can you pull them up from last time?
Here, let me see what I'm gonna do.
Actually, what I'll do here is I'll draw them. That will be that'll be good. I was looking for a few more here. All right. Just trying to figure out where we're gonna go next. Okay, let's do this one here. Um, based on based on what's here, there's four possible graphs that it could be, and that's what you have to be able to figure out here. Is it the one that this one, the one on the left, the one on the second one? So that's what you have to figure out from this without a calculator. And so it's based on the degree, whether it's odd or even, and the leading coefficient. And that's just kind of wondering if you still have those graphs up or a reference sheet.
Oh, I- here's one of those. So for the degree in this case, it'd be 7. Leading coefficient would be -2, so it would be odd.
Okay. Leading coefficient is negative. So the odd ones are over here on the right. You know, this is odd,
Yeah.
even, even, and then leading coefficient positive, negative, positive, negative.
So in this case,
A is often the leading coefficient.
all right. So then that
All
would
right.
mean that the last one, the one
Yeah.
where it's a direct
So
line.
what I'd like you to do is try to write the end behavior like I did here for that last one. And then I'll write it down as well. But if you could just give a
So would it be x is positive infinity, then y would be negative infinity?
F of X.
F of
Typically
x.
F of X is used. You can use Y, but it's typically F of X. Or in this case, you would use H of X. Your instructor might do that. Just depends on what they see.
And then other one would be as x is negative infinity,
Okay. F of
y
X
is
goes to F of X
negative.
goes to which infinity? So
Negative infinity.
so that would be down here where my
Oh yeah, right. The y. So then you're on the positive end of the y. So the positive.
yeah. All right. Any questions on that?
No.
Okay. So you might think, oh, I've got it, or makes a lot of sense. What they'll end up doing is giving you a problem that looks like this. And they'll ask you for the same thing that I just asked you, what's called the end behavior. Now, what you don't do is you don't have to multiply the whole thing. Now, we will for the first one just to get some practice at doing that, but in general, you don't have to do that. So this is x cubed minus 5x squared minus 4x plus 3x squared minus 15x minus 12, x cubed minus 2x squared minus 19x minus 12, like that. And now you have it in the form that you want. But was there a way to get it without doing all that? And the answer is yes. The answer is yes. Like you could have just recognized that it's the leading one times the leading one. All right. So this one has, you go back, it's odd. It's got a greater than 0. So we got this and this. So could you give me the end behavior for this, please?
Behavior for that would be
Yeah.
so as x is positive infinity,
So that's to the right. So that's this one up here.
y in this case would be uh so x is positive infinity, y is positive infinity,
Yeah. Okay.
and
And
then
let's go the other direction as x
as
goes to negative infinity.
x goes to negative infinity, y goes to negative infinity.
Very good. Okay. All right. So now let's look at another one that's slightly more complicated. All right. So like the last thing you want to do is multiply this all out. That's way too much effort. Okay. So what you have to sort of identify is like, what's the biggest thing that you're multiplying? Well, there's an x cubed, and then this middle one, there's going to be an x squared at some point. Do you agree with that?
Yeah,
Times the x from this one. So this now becomes x to the 6th power. X to the 6th power.
wait, wouldn't you add the x? Oh yeah, you'd
Yes.
add the
And that's
exponents.
and that's what I did. Yeah, good question here. Yeah, it's 3 plus 2 plus 1 x to the 6th. And then if like this one doesn't have a leading coefficient, we'll do some like those at some point, but the leading coefficient is 1 here, so this is even, and a is greater than 0, so the graph is high and high. As x goes to infinity, what happens to y?
If x goes to infinity, y, uh, a positive infinity,
Yes.
and then the other one would be as x go to negative infinity, y would go to positive.
All right, so let me give you one to try. Let me know if you need another moment to write anything down.
All right, I got it.
All right, so let's go f of x equals x squared plus 3, x minus 1 squared. So I'm looking for the end, just the end behavior. I'm going to just step away for 30 seconds, but I'll be right back with you. All right, Karthik, what did you get for the degree? Is it even or odd?
What's out? Oh, so big. Yeah. Okay. All right, I think the degree is 3.
So it's x times x squared times x squared. Why is the last one x squared?
Wouldn't you expand it?
You don't have to expand these, and that's the whole point. I don't want you to expand these because they take too long. We just need to know that it's degree 5. Like, okay, so you want to expand this one on the right, and that's fine. It's x squared minus 2x plus 1. But then you're going to multiply it by this x
Oh,
squared times
I
this x. And
added,
that's the whole
yes,
point of this.
yeah, I forgot about the parentheses there. That's fine. I didn't do some, I added it back. That's probably what I got. 3. So it would have been,
Okay, so now is it positive or negative, the leading term? And it's based on the sign of the x squared, and the x squared. So it's positive.
Positive.
So the graph looks like this, low and high.
Then as x is positive infinity, y is positive infinity. As x is negative infinity, y is negative.
Sorry, I wasn't paying attention. You said f of x goes to.
Yes, that'd be positive infinity, and then the other one would be as x is negative infinity of x is.
Okay. So what I'm trying to show you here, and I guess we'll spend a little bit more time on this. I didn't know, how much of this we were going to need to dial in, but like, let's say it's x minus 1 times x plus 3. You know that this produces an x and an x, like x times x, if you were to multiply it out. Do you agree with that?
Yeah,
And then if I put like an x squared minus 5, you're eventually going to multiply by x squared.
wait, so then what happens to the negative 1, positive 3, and negative
You don't care
5?
about them. The point is you don't care about those.
Oh, so you just take the x, whatever exponent is
Yeah.
attached to it, and then, okay.
Yeah. Now let's just say I had one more thing. I had x minus 1 or x plus 1 cubed. This produces an x cubed, and that would come down here. So you grab like the leading powers.
Got it.
All right. So let me try to give you one to see if you've got this down. So let's say it's a x cubed minus 5 times x plus 1 squared times x minus 4.
All right. So I got, um, yeah, x to the 6.
So we have an x cubed, we have an x squared,
Wait, yeah,
and then just an
yeah,
x. Good.
x.
Good. Okay. So that gives you x to the 6th, and then you can figure out the end behavior from there. Now, um, another thing is another thing here is what if like the coefficients are changed? Like let's say it's like 2x squared minus 1 negative 3x to the 4th plus 5, right? So we know that um, uh, it becomes negative 6x to the 6th, like that. Like you multiply the coefficients.
So can you repeat that?
Is that clear how I got that leading term?
So yeah, you just, yeah, I got
Now,
that.
the thing is though, is we can extend this. Like what if it's like minus 3x plus 2? Okay, so then what is it? Well, um, it's 2x squared. You bring that down. Minus 3x to the 4th, you bring that down times minus 3x. And that leading term of the whole thing ends up becoming 18x to the 7th.
Wait, how do you get x to the seventh again?
2 plus 4 plus 1.
Ah, got it. Yeah, okay.
Right. So like what you have to be able to do is figure out, and this is what's called the leading term. You have to be able to figure out the leading term. Okay. So let me look for some problems here um, for us to do, or I'll just make some up. But it's really important because it helps you to identify, the end behavior. So like this leads to the end behavior. All right, so let's see if any of these have it. Nope. Um, all right, let's make one up here. All right, so let's go x squared minus 1, 3x plus 2 minus 5x plus 3 times I'll just put an x here out in front. Okay. What is the leading term?
The leading term,
Hang on just a second. Be right back. All right, Karthik, how, what did you come up with here for a leading term?
Leading coefficient or
Yeah, sure, go with that.
I got -15
Okay, and then it's x to what power?
to the fifth power.
Very good. Okay, so tell me, what does the graph look like? Are the arrows in quadrant one, two, three, or four? Which quadrant are they in?
It's odd, so it would be quad wouldn't it be quadrants 1 and 3?
If it was positive, but it's negative, so it goes in these. So you have to get like if you want to like what's the most important thing from today? It's knowing these four graphs. 100%. Okay. So could you give me the end behavior now as x goes to infinity? We'll just call it y. As x goes to negative infinity, we'll call it y.
So as x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to positive infinity.
Okay, good. All right. Um, Excellent. Okay. So here's some other things that could happen. What if the polynomial is written this way? 2x minus 1 times 4 minus x. This time, this time you have to extract the 2x, and then this is negative x. Okay. See, is that clear why that would be? Because the negative goes with it.
Yeah,
All right. Now, what if it's even more like messed up? What if it's like 2x, sorry, that's not a bad, minus 3 squared. What is this? Well, it's the 2x squared. So now you have to square this.
so after that, once you get -8x to the fourth, if you were to multiply all of them,
Yes, exactly, exactly. So now tell me again, which quadrant are the arrows in this case?
if it's -8 to the 4,
I'm sorry, which one?
uh,
I just didn't hear. I thought
uh,
I kind of,
if it's -8 to the fourth negative, so it's eight. So the second quadrant and the fourth quadrant.
the down here and down here.
Oh, right, good. This one's even, yeah. This one's even, not odd. Yeah, so that'd be the third one, third quadrant.
So now the end behavior here, as x goes to infinity, as x goes to minus infinity.
As x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to
All right, good job. Okay, let's try another one here. Let's go. negative 4x plus 3, 1/2 x minus 2, x squared plus 1 squared. Go ahead and figure out um,
All right, I got negative 2x to the sixth.
that's correct. Very good. All right. So we already did one like that, so we'll do another one here. And then do you have something else you can send over for us to work on?
Yeah.
Okay, why don't you get that? Actually, why don't you, we probably hashed this out enough. Why don't you grab something else and we'll see what we can do for the last 10 minutes.
All right, let me grab that. All right, so there's 4.2 part two, so let me grab.
Okay.
So part two is in the chat now.
All right. Well, it's let's see what we just went over. Um, yeah, okay. So the other thing here is we can talk about roots and multiplicity. All right, hey, I'm sorry, Karthik, I was muted. Oh my gosh, having just nightmarish day. Uh, the factors are what's inside parentheses. That's probably clear. Okay. The roots are the numbers that make this zero. Okay. The multiplicity, where do you think that comes from?
The exponents.
Yeah. Okay. Um, the behavior is the following: crosses, and touches. And the behavior refers to the x-axis. So I'm going to put a graph up of this, and you'll see what I mean here by doing this. So we got x minus 3, x plus 4, x minus 5 squared. All right, so I got to zoom out. Uh, so here we go. Get a nice little snip of this. So when I say crosses at 3, this is 3. That's what I mean by crosses. When I said crosses at -4, that's what I mean by that. At 5, it touches. Is that kind of clear?
Yeah.
What I mean by the word cross and touch? So this table, I don't know how much of this you'll need to populate, but the factors lead to the roots. The roots tell you the multiplicity. Okay. And the behavior, what you have to remember is it crosses if it's an odd multiplicity, and it touches if it's an even multiplicity. That makes sense? Crosses the odd ones, touches the even ones. Is that okay?
Uh, yeah.
All right, so let's do another one here. Let's say it's x plus 1 squared, x minus 4, x plus 2 squared. Okay. So let's do this one at a time. Factors. What are the 3 factors? What are the 3 things in parentheses?
There's our x plus 1, x minus 4, and x plus 2.
Okay. And then the next thing is the 0 or the root or the 0.
That would be 2, 1, and then 2 again.
That's the multiplicity. The root
Oh,
0 is
the root. So
setting
that
them
would
equal to 0.
that'd be -1, +4, and -2.
Good. And the multiplicity is 2,
2.
1, 2, like you said. And then I like to add in this one. This is me. The behavior, touch, cross, touch. Okay. And let's just say this was like, and actually I should probably change this. Let me change this to a 4. Now let's change this to a 3, because you need to see an example where if it's even, it touches, and if it's odd, it crosses, even if it's 3 or whatever. Is that okay?
Yeah.
All right. Does this seem difficult to you?
So far, it doesn't seem that hard yet. But
Yeah, this one's kind of hard to see graphically. Dang. Let me change my window here a little bit. Let's go up just 20. That's too much. Go 2, 2. Boy. Ooh, okay. So let me grab him. Minus. All right. Um, yeah, like I made this so extreme, it's hard to see with a graph of what it does here. Let me snip it in real quick, see if we can make some sense of this. Um, all right. So um, yeah, we got at -1, it touches, at -2, it touches, and you really can't see it, but it just comes up and touches, it comes down a little bit. And then at 4, it crosses. You can see that. All right. So where we're going with this is you're supposed to be able to take something like this, the following like this, negative x plus 2, x minus 4, x minus 1. And you're supposed to be able to graph this without a calculator. You might think, well, how can I do that? Well, you do what we just did. You figure out that at -2 and 4 and 1, these are the roots, and it's got a multiplicity of 1, multiplicity of 1, multiplicity of 1, which means that it crosses at each of those. Now, what you don't know is whether it goes up or goes down through there. You don't know whether it goes up or goes down through the up or down through up or down through there. But what you can figure out is that leading coefficient. You can figure out that this is negative x cubed, which starts high and ends low. And then that helps you to figure out, okay, I must cross, come down, cross, come down, something like that. So that's where you're going. You're going to be expected to graph these things on your own, rough sketch like this, label the places where it crosses, and go from there. And you'll be able to do that. Truly, you will. So if it were me, and I had extra time, and I'm not saying this that you have extra time, I would actually try some of the problems that you guys were given in class. We covered enough to do all of this. Just give you an example of like this one here from today's lesson. Like if you had on your own, you actually know where the x-intercept starts. The x-intercepts, those are the roots, those are the zeros. So it's -20, -5, and 4. But I would do it the way we were doing it, which is building a table: root and multiplicity, multiplicity of 1, 2, and 1. The y-intercept is when x equals 0. The degree you get from the leading term, this is an x times an x squared times an x, which is x to the 4th. So it's degree 4, it's even. The leading coefficient is 1. Like we did all that, it's positive. And so now, and then you can draw a quick sketch of it. It's going to look something like that. And then you can do your end behavior. And that's kind of the speed at which you want to be able to work through something like this, which is probably feels pretty fast, but you can do that now. You really can. You'll notice that 3 and 4 in your assignment practice notes, they've got fractions. Just ignore those. You only care about the sign. Only the sign matters. All right. Let's stop there for today. Before you run, I know you